All right, welcome ladies and gentlemen. This is the first video in the organic chemistry unit, first flip video. It is on naming and drawing alkanes. So this is starting on page 4 in your notes. So that's where you should be. So the first thing that you need to do if you're naming an alkane that has substituents on it is to determine the longest chain and name it. So find the longest carbon chain, name it based on the number of carbons it has in terms of the prefix, and then name it in terms of the suffix, in terms of the type of bonding. And that is what we're going to call our base name. Then, after you've done that, find your substituents and name them. Now remember, substituents end in YL, but they use the same prefixes for the number of carbons. So like a one carbon prefix, a one carbon substituent would be methyl, because meth means one carbon and il means substituent. Then you want to number the carbon atoms of the main chain. This is a key point, so that the substituents are closest to the very first carbon. So basically you can't just name the longest carbon chain and name the substituents. You also have to number the longest carbon chain so that you can give the substituents an address. You have to say in your name where the substituents are and say which position they have on the longest carbon chain and include that actually in the name. So numbering the carbon chain is going to be your next step. The way you number it is right here. Because you're always going to have two choices in terms of numbering the carbon chain. Basically, do you number your chain left to right or right to left? Your answer to that, which was it going to be, is based on putting your substituents closest to the number one carbon. Your substituents should be closest to the number one carbon in your chain, whether that's the carbon on the right or the carbon on the left. Then you essentially put everything together. So you have your base name with your longest carbon chain. And that's comes at the end, and then the substituent names with the numbers become prefixes for that main carbon chain. So it's like we have our longest carbon chain at the end of the name, and then we simply start building prefixes in front of it in terms of what are the substituents and where are they. Now, if you have more than one of the same substituent, then we use the prefixes di and tri, and every single substituent needs a number. So if you have, let's say, 3 substituents on your main carbon chain, you need to have 3 numbers in the name, even if it's on the same carbon. So that's a key point. So the number of substituents you have, that's the number of numbers you need in the name. If you have more than one substituent, for our purposes, we're simply going to list them in order in front of the base name. So you just sort of put them all in front. So for example, so we're going to name this carbon, name this carbon compound. And the first thing we want to do is determine the longest carbon chain and name it. So this will become our base name. So we have this compound right here, and it should be fairly obvious that our longest carbon chain is right here. It's already counted out for you. This is our longest chain, so this will become our base name. And we counted up. There are 7 carbons that are in this chain. They're connected with single bonds. So we want to use the prefix hept, indicating 7 carbons, with the suffix ane, indicating single bonds. This is a heptane molecule. This is going to be our base name. This is going to come at the end of our name. We're going to build everything else out in front of that. Once we found the longest carbon chain, so we've already dealt with this portion right here, we want to find all of the substituents and name them. So what are the things that are attached to this long carbon chain that are not hydrogens? Remember, hydrogens don't count. Hydrogens are automatic. So first of all, I have this. This is 1 carbon. It's a substituent, so its name is meth, indicating 1 carbon, and with a YL suffix indicating substituent. So the meth means 1 carbon, the YL means substituent to the longest carbon chain. So this right here, this is a methyl group. And then looking on the bottom, we also have this. This is a substituent. Again, this is 1 carbon, it's a substituent, so this is also a methyl group. And then I have this right here. So now I have 2 carbons in a row. 2 carbons are connected to one another. This is also a substituent, but it's not going to be a methyl group anymore because it's 2 carbons. It's going to use the prefix eth because it's a substituent. It's going to end in YL. So this right here is an ethyl group. So essentially what we have right now in this compound is we have a heptane for the longest carbon chain, and attached to the heptane we have a methyl group, and an ethyl group. So our name is going to involve all of these components. The next thing that we want to do is number our carbon chain. So this is a key point, because it's not enough just to say that we have a heptane and 2 methyls and an ethyl. We have to say where the methyls and the ethyl are on the longest carbon chain. Number your carbon chain, making sure the substituents are assigned to the lowest possible numbered carbons. You always have 2 choices for how you number the carbon chain. You can number your carbon chain left to right, which is shown here. So you notice I start with number 1 on the left and I end with number 7 on the right. Or you can number your carbon chain right to left. Again, so this is shown here, starting with number 7 on the left and having number 1 on the right. And again, I'm simply focusing on the longest carbon chain. That's what we're numbering. We're not numbering the chains, carbon chains and the substituents. I'm just numbering the longest carbon chain. So I have 2 choices, and the one that's correct will have the substituents. So I'm paying attention to this, this, and this on both of these. Have the substituents on the lowest numbers. The lowest numbers. So in this choice here that's on the left, I have carbons, I have my substituents on my number 3 carbon, my number 5 carbon, and my number 6 carbon, right, shown right here. So this is the substituent that's on number 3, the substituent that's on number 5, this is substituent that's on number 6. On this one that's on the right, I've got my substituents on my number 2 carbon, on my number 3 carbon, and on my number 5 carbon. I want to number it so that my substituents are on the lowest possible numbered carbons. So I look at these choices, and 2, 3, and 5 is lower than 3, 5, and 6. So I am not going to number it in this case left to right. I am going to number it in this case right to left, because it puts the substituents on the lowest possible carbon. So in this case, I'm numbering my carbon chain right to left so that my substituents are in the lowest possible numbers. And then we simply assemble the name. So we start with our base name at the end, and then we add in the names of the substituents, but we include where they are. So what I mean by that is this right here, this is a methyl, but it's on the number 2 carbon. So I actually stick a 2 out in front of the methyl prefix. So this isn't just methyl, this is 2-methyl, indicating that the methyl is on the number 2 carbon in the chain. Likewise, this, we established that this is a methyl group, but it's a methyl group that's on the number 3 carbon, so this is 3-methyl. This right here, we established that this is an ethyl group, but this is an ethyl group that's on the number 5 carbon, so this is 5-ethyl. Before we assemble it into the name, notice that we have 2 substituents that are actually the same type of substituent. I have 2-methyl and I have 3-methyl. Because these are the same, I'm going to not say methyl twice. I'm going to instead say dimethyl, so that I don't say methyl, methyl. But I have to include the numbers. So this 2 and this 3 are going to become 2, 3 dash dimethyl. So instead of saying 2-methyl, 3-methyl, I say 2, 3 dash dimethyl to indicate 2 methyl groups. Okay, so assembling the names. Start with my base name. So this entire thing was a heptane, right? Because 7 carbon chain. So I'm going to put that at the end. That comes at the end. And then out in front of that, let's see, what did I have attached to that? I had attached to that a 5-ethyl group. And then I also had the 2 methyl groups, so 2, 3 dash dimethyl dash 5-ethyl heptane. And that right there is the name of the compound. So again, we have our longest chain, we have a substituent, we have location, we have substituent, and we have location. And that is how we name an alkane. So the name of this compound is 2,3-dimethyl 5-ethyl heptane. That's the name of the compound. It's a very descriptive name. It's simply saying what is the longest carbon chain, what are the substituents, and what are attached to them. So looking at 2 more practice problems, and these are just inverted orders from what you have in your notes. So you're simply going to flip-flop the order of these. So name the following compounds. So the first thing we want to do is find the longest carbon chain. Longest carbon chain is here. That's 4 carbons. They're connected in a single bond. So I'm going to start my name with butane at the end. Then you want to find the substituents and name them. So I have Cl. So that's chloro. Remember with the halogens, we don't say like chlori or chloryl. We say chloro. They end in O. This is also chloro. So I have 2 chloro groups that are attached to this butane. So I've named the substituents. Now I want to number the carbon chain. So I could number this left to right, 1, 2, 3, 4, left to right, or I could number it right to left, 4, 3, 2, 1. Now in this case, notice it actually doesn't matter if I number it right to left or left to right, because in each case I have a chloro on the number 2 and the number 3 carbon. So in this case it actually doesn't matter because we wind up getting the substituents on the same numbered carbons either way. So I want to add to my name, so this is not just chloro, this is 2 chloro, and this is not just chloro, this is 3 chloro if I'm going with the left to right numbering. But remember, I don't want to say 2 chloro, 3 chloro, because these are the same substituent. I want to instead say dichloro, so I'm going to stick that in front of the butane. And I have to say where they are, so I have to keep these numbers, the 2 and the 3. So this is going to be 2,3-dichlorobutane, and that's the name of the compound. Again, we have our longest chain. We have the substituent, the name of the substituent, and we have the location of the substituent. So that's how you name a carbon compound, an alkane. And one more. So this one on the bottom here, which is the first one in your notes. First thing you need to do is find the longest carbon chain. Now I have to be very careful here because the longest carbon chain is the longest chain of connected carbons, right? So the longest chain of connected carbons is this, right? It's 5, it's not 4, because I can go here and then I can still go down without taking my writing utensil off the page. So it's the longest carbon chain of 5 carbons. So 5 carbons was connected by nothing but single bonds. That base name is pentane, right? So then I want to find my substituent. So this is attached to the longest carbon chain. It's 1 carbon, which is meth. It's a substituent. So it's going to end in YL. So this is a methyl group. Then I need to number my longest carbon. I need to number my longest carbon chain so that the substituent is on the lowest possible number. So I could either go 1, 2, 3, 4, 5, left to right, or I could number right to left. So I could go 1, 2, 3, 4, 5. And the way we know which one is correct is by which one gives us the carbon, the substituent on the lowest number carbon. So notice how if we number it, in this case, left to right, 1 to 2 to 3 to 4 to 5, that gives me the substituent on the number 2 carbon rather than the number 4. So I know that I'm numbering it in left to right in this case. So this here isn't just methyl, this is 2-methyl. And then I'm going to simply take the name of the substituent and stick it out in front of the base name. So this compound is 2-methyl pentane. Again, we have the longest chain. Coming at the end, we have the name of the substituent, and we have the location of the substituent. So going in the other direction, if you're asked to draw an alkane is to actually go in the opposite direction from what the name says. The key to drawing alkanes from a name, rather than being asked to name a compound from the structure, is to start with the end of the name. Work your way forward, meaning draw the longest carbon chain first. That's at the end of the name. And then sort of work your way up through the substituents and put them in the correct place. Always ensure, this is huge, hence the enormous font, carbon gets 4 bonds. Carbon only gets 4 bonds. It does not get 5, but you have to make sure it gets 4, not just 3. So you have to be very careful when you're going through and drawing carbon compounds to making sure that every single carbon has 4 bonds. So change this first one from your notes to 2-methylhexane. So if we're asked to draw that, we want to start at the end, at the very end of the name, hexane. So what does that mean? Hex is a substituent, is a prefix that means 6 carbons. Ane means single bonds. So I'm going to draw 6 carbons connected by single bonds. So that indicates the hexane. Then I'm going to work my way forward. This thing right here, meth, that means 1 carbon. Il means that it's a substituent. So I know that I have a 1 carbon chain that is a substituent that is attached to this 6 carbon long chain. Well, I have lots of places where I can put it on the chain. How do I know where I'm going to put it? With the 2 out in front. So that's my location. So I know at the number 1, number 2 carbon, I have a methyl group, 1 carbon, that's attached to it, and that is a substituent. So I could also have drawn that on top. I could also have started numbering my carbon chain on the right-hand side and put it on the second one in from the right-hand side. But I'm not done yet, because I need to make sure that each carbon gets 4 bonds. So if I look at this very first carbon on the left, it already has 1 bond, so I have to give it 1, 2, 3 more. This second carbon, and notice it already has 3 bonds, so it only needs 1 more. Don't forget about your substituents. They need 4 bonds too if they're a carbon. So this carbon only has 1 bond already. I got to give it 3 more. This next guy is 2, so I got to give it 2 more. Needs 2 more. Needs 2 more. And this last guy needs 3 more. So that right there is the structure for 2-methylhexane. And then the last one, 3-chloro-1-iodoheptane. So I start at the end. Heptane, hept means 7. Ane means single bonds. So I'm going to draw 7 carbons connected in a single bond. 1, 2, 3, 4, 5, 6, 7. All right, and then let's see, I have this right here. So iodo, so that means an iodine. And where is that iodine? Oh, it's on the number 1 carbon. So put an iodine on the number 1 carbon. And then I have 3-chloro. What does that mean? Well, that means I've got Cl. So I know I have to put a Cl somewhere. Where do I have to put it? Oh, I have to put it on the number 3 carbon. So I'm going to put it there. Now, halogens only make 1 bond. That's it. Because they have 7 valence electrons, so only 1 bond to get to 8. So I don't need any more bonds for the iodine and the chlorine. They're done. Do not give them any more bonds. But I do need more bonds for the carbon. Carbon gets 4 bonds. So I look at this first carbon in the chain. It only has 2 bonds, so I need to give it 2 more. Second one only has 2 bonds, so I need to give it 2 more. Third one already has 3, so it needs 1 more bond. And then let's see, 2, 2, 2, and 1, 2, 3. So those are our notes for this video. Tomorrow you will be practicing this on both pencil and paper, but also with a modeling kit.